This meeting is being recorded.
Hello, everyone. Good morning, good afternoon, good evening. Thank you so much for joining us today. My name is Rigo Villa. I'm one of the community managers on the Cisco Learning Network, and I'll be your host today. In this session, we're going to be covering IBNS 2.0 switch templates for ISE deployments with our speaker and presenter, Brad Johnson. But before we get started, I wanted to share a couple of quick housekeeping notes. First, I want to let our attendees know that if we run into any technical issues during the webinar, we'll do our very best to resolve it as soon as possible. So we just want to thank you in advance for your patience and understanding. Next, if you have any questions during the session, we ask that you please post them in the question and answer panel as displayed on the screen here in front of you. This will help our panelists manage and keep track of all of your questions and would also allow them to provide you with a much more timely response. Also, if you experience any audio streaming issues during the live presentation, I do recommend using the call-in telephone number that I'm going to be posting in the chat window here in just a moment. And at the end of this webinar, you're going to get a pop-up survey with a couple of questions about today's presentation. And we would really appreciate it if you can just take a moment to fill it out and share with us any thoughts or feedback that you may have about today's session. I also want to let our attendees know that this session will be recorded and will be available on demand within approximately 5 business days after today. And I'll be sure to share some more information about that a little bit later on as well. Also, we are going to be launching a few poll questions using Slido, and when it's time, you will see the Slido pop up on your event screen, and then that's when you'll have an opportunity to submit your answers. So we look forward to your participation. And last but not least, I want to let everyone know about our next webinar coming up. So that session coming up on November 5th, we're going to be covering ISE integration with Splunk. And I'm going to be sharing some information on how you can register for this upcoming session a little bit later on as well. So without any further delay, I am now going to hand it off to our speaker to get us started. So Brad, if you're ready, please take it away.
Thank you, Rigo. Hi, everyone. Thank you for attending this webinar for IBNS 2.0 switch templates for ISE deployments. My name is Brad Johnson. I'm a security consulting engineer with Cisco. A little background about me. I actually started working with Cisco NAC long ago at a school district that I worked for, and it was going end of life, end of support, and Cisco came along and said, hey, we got a new product called Cisco Identity Services Engine, or ISE, and we'd like you to replace your aging NAC with it. And so I did, and that was ISE 1.1, so pretty old version. Was able to deploy that to about 40 schools in our district at the time, and worked my way up. Later, started working for a partner because they heard, hey, you know how to deploy ISE, we need somebody who can deploy ISE. So that's what I did. Worked there for a few years. That's where I actually started my website, ice-support.com, which some of you may know me from, where I post configs that I've worked on for customers. I've post my templates there. That's where a lot of them are found. The name of the website was kind of a joke. Worked with Catherine McNamara, talking to her about it, and she's like, yeah, you should do it. And I was like, yeah, I should. And after I did, I was like, oh, maybe that wasn't a good idea, but it is what it is. So after working at the partner for a few years, now I'm at Cisco, helping out and get to actually do a webinar on it. So let's get started. Just to let you know, ISE 3.3 patch 3 is the current release that is suggested for deployments. So make sure you keep up to date on the release notes. Always read the release notes before you deploy new versions of ISE and new versions of patches. What I expect to cover today with you is a quick overview on identity-based networking services, which is the IBNS, understanding a lot of the key features of the templates that I have, that I've used and shared out. That'll be the bulk of the conversation. And then we're going to round it out talking about something that we see a lot of questions on, concurrent MAB and .1x. First slide of question we have for you is, have you deployed IBNS 2.0 in your environment? Have you started playing around with it some? Have you done it in your lab? Getting into the quick IBNS overview. What is IBNS? So IBNS is the framework for all our policy decisions based on the identity of a user account logging in, of a device trying to connect to our network. IBNS 1.0 was originally released in 2013 in early versions of iOS 12. It gave us authentication with 802.1x, MAB, WebAuth, and so it was the main way to configure switches when deploying earlier versions of ISE. And so then IBNS 2 came out because it can be better. We needed some improvements. So why do we have a new version of IBNS? Awesome new features. Flexible authorization is based on different authentication methods. So if we have a failed authentication, we can authorize that, put them in a different VLAN. We can do some WebAuth based on MAB. It's a modular environment. And we can have it all based on how we configure our policies on the switch itself. My favorite part, interface templates and the modular configuration of it all. Because now instead of having to put every single command on an interface, we can create a single template, assign it to the interface, and have it run. Service templates are what we use for things like assigning critical VLANs, critical ACLs, and we can all base that off of either a policy map setting, which we'll get into later, or even assign from an ISE authorization profile. And then the critical ACL HTTP assignment. If, let's say your switch goes completely offline, your AAA servers go offline, or your WAN connection goes down between your site and your ISE nodes. Before, it was just unauthorized. No one could get connected. No one could get any kind of information on the network because it would just be stay in an unauthorized state. Whereas with IBNS 2, we can assign a critical ACL, we can assign critical VLAN and an SGT so that devices that we want to make sure can get on no matter what, and at least to connect to local resources, can still get on. And we'll cover that later as well. So let's get into the template configs. That's what everybody's here for. True or false? IBNS 2.0 must be enabled before you can enable device sensors. So when we're talking about these templates, what I built them for mainly was because I was going to so many different locations and I was having to build out configurations for their switches, and I started noticing a lot of commonality between them. So instead of having to reinvent the wheel every time, I started creating templates with placeholders for things like IP addresses and server names so that I could just copy, paste, be done, and run it out. I also tried to streamline those so that we had just better configs, like using named radius groups in my AAA configuration. This is useful when swapping out the different AAA servers if you're migrating from one to another. Also have beyond the basic radius configuration. So adding some extra configuration to the radius config just to help improve it, and we'll see that in the examples. And also enabling device tracking, device sensors. That's a big one that really going to enjoy working on and seeing how that operates. First off is my radius configuration. Use a radius test account. It is optional, but it's not optional because it really does help. Whenever you have a radius server go down, if the switch tries to send an authentication request to a server, there's a timeout. If it doesn't receive a response, it marks it as dead, and then it starts a timer of when to try to start sending authentications again to it. The problem with that is if it's continually down, it's going to keep flapping up, try to send it off, time out, go down, and keep repeating until it's up. The radius test account allows the switch not to try to bring the connection back up. Instead, if a server is marked down, I'm going to send this test username and this password that's configured at the top to that server. If I receive no response, it's going to wait until another timeout to send another single test account. All other authentications, though, will keep going to whatever radius server is still live. So you're not going to be waiting for timeouts of user authentications, only the test account. And to keep in mind, the test account, it doesn't have to receive a successful authentication. A failed authentication would still consider the server alive because the switch received a response. That's what the key. It's wanting a response. So no response, server dead. Any response, pass fail, server up. Then the ignore accounting port, the reason I have that in there is because there is no response on accounting. So there's no reason to monitor that port. We only care about the authentication port. Using the names, it is important that whatever server name you configure in that top, you use the same name in the group at the bottom. Case does matter. So if you don't type it exactly the way it is, it's not going to work. It'll accept it, but it won't send authentications because there's no radius server configured by that name. And the nice thing about using the groups is you can control what order the servers are assessed. So whatever server you put in slot 1, that's the first one it's going to connect to. If it's down, it'll move on to server 2. And you can put in more. I just have 2 as an example here. The PSN IP, this will vary because you can have either a direct IP address to the PSN, or if you have a load balancer, which we highly recommend using, this is where you would put the VIP, the virtual IP address of the load balancer. So even though you have the ISE PSN name, which can be any descriptive name, doesn't have to match the exact name, just give it a descriptive name. Some of my customers, they'll use like data center -VIP-1 or whatever, and that way they can keep track of it. It's just this is what you use to say, send this traffic to this IP address. And the name is only there so that you can use it in the group. And notice the group server radius at the bottom left, where we call it ISE-radius. Where that comes into play is in our AAA configuration. Very first off, some of the older versions of iOS don't have the full AAA feature set enabled. That's why you have to run the AAA new model command. So I include that in my templates as well. Then when we get into the actual AAA configuration, that's where that group name is. That's why you can create multiple radius groups on a switch, swap them in and out in your AAA, and that'll determine where the authentication goes, where the authorization goes, and where the accounting goes. Now, by default, accounting updates occur very frequently, and there's no reason to. When a session is live on ICE server, ICE will keep it for 5 days if no accounting information is changed. So you plug in a printer. Printers usually just sit on the network and just sit. So that session's live. After 5 days, if ICE doesn't receive any accounting updates, we're going to mark that as no longer a valid session. So it's going to tear that session down in ICE. What we're telling the switch here is, hey, every 2,880 minutes, which is 2 days, just send an accounting packet for that session. Because that 2 days is less than the 5-day counter in ICE, so that we maintain that session information. And then the dynamic author configuration, this tells the switch, if you receive a COA from this IP address, accept it and do whatever it says. Because if you don't put the IP address of your PSN or your virtual IP address, the VIP of the load balancer here, and you send a COA to that switch, the switch will reject that packet. So if you ever have COA issues, hey, I'm trying to bounce this connection, it's not working. I see an ICE where the dynamic dynamic packet failed. Check your dynamic author setting to make sure that it is accepting from either the PSN or the VIP. Now with the VIP, this is the one time where SNAT going from the policy node to the NAD is acceptable. Because if you look at our configuration examples, Cisco provides great configuration examples for F5 load balancers as well as Citrix NetScaler load balancers. You will see that SNAT or RNAT for Citrix is not supported going from the network device to ICE because ICE needs to receive the IP address of the network device. Going the other way for COA, COA is initiated from the policy node. So it's acceptable to send that traffic, have it NATed so that the switch receives it from the IP address of the VIP. Simplifies configuration because if you have 10 policy nodes behind a load balancer, you don't have to put 10 dynamic author entries. You put one VIP and be done. Here we'll have an example where I'm going to apply a radius configuration to a switch that had no configuration. That's why the first test, we do have a test AAA command built in the switches. The first test, it's going to fail because there's no AAA configured. And then on the second test, we'll get a failed authentication, but it's a response. So no authoritative response from any server. That means it did not receive anything, pass or fail. Put in the ICE configuration, rerun it. Authentication was rejected. So we received a response. That shows that we do have connectivity or authentication between the switch and the policy node. And that's what the automated tester would look for. One thing you can do, you can create the test account as an inside user, an internal user in ICE, and configure a policy set to accept that. If you want to be able to send back a pass authentication for it, you just have to make sure that the username password matches whatever you configure on the switch itself, which you can see I have a super secure password for the username radius test on this one. Device tracking, this one is very important. If you don't configure device tracking, you're going to run into random issues like profiling can fail. Downloadable ACLs will fail to assign. I actually had a customer where they were trying to test out posturing. ICE was sending back the correct authorization profile, but none of the clients were getting the redirection for posture. When we checked the switch config, they had no device tracking configured. As soon as we enabled device tracking and assigned it, everything flowed as it should. And like it says at the bottom, no, device tracking is not optional. In the configuration of device tracking, you have a lot of options. I found that these are usually sufficient for most places, but we have a lot of documentation on it. If you want to see additional settings for device tracking, very first one, this is going to be for the endpoints, and we're calling it IP tracking with a security level of glean. Now, what glean is it passively captures the data. So it's going to add it to the device tracking database passively, not act on it. The default is guard. And the problem with guard is sometimes if something is off, it will drop the packet and the endpoint's marked as unauthorized immediately. Whereas clean, we don't have that issue. We're going to limit that address count to 10. Now, I know you're saying, my switch, I've got 48 ports, I got way more than 10. This is a per port device tracking policy. So we're going to limit the device tracking to 10 on a port. You can easily up it to 1,000 if you wanted to. Not sure why. And then we have tracking enable, obviously, in order to enable the policy. No protocol UDP. Don't really need to track UDP on it. Some of the other versions of iOS 15, I believe, it actually, you could enable protocol UDP, but it didn't actively track it. So I just put in no protocol UDP just so I could call it out. You'll see that in some of my templates where a lot of default settings I actually explicitly call out just because I don't know who may have changed it, who may have changed that default setting, and I want an optimal configuration, in my opinion. So I want it enabled. So if they've disabled it, I'm enabling it. And then lastly, you see interface gigabit. We attach the device tracking policy to that port. It has to be attached to the port. If you don't attach it to the port, it's not going to track on iOS 16.3 and up. The next policy is the trunk. I actually created a tracking policy for trunk because we don't need to track on a trunk. We only care about tracking on an access port. And all you're doing, if you don't disable tracking on a trunk port, you're just doubling up the information. So we set it to a trusted port, and we tell it it's a switch. The device role is a switch. And then on the interface itself, the actual trunk port interface, we attach the policy. And one thing I've come across in several locations, this started way back as well, is sometimes when you have device tracking enabled because it uses ARP for this, Windows clients would connect, and when it would go request a DHCP address, it would pop up an error that a duplicate IP address 0.0.0 was detected. And it drove me nuts because I'm like, what is this? Why does it matter? What is 0.0.0? It's because we needed to source the device tracking. So it is two different commands. iOS 15.2 and up, or iOS XE 3.3 and up, use the IP device tracking probe auto source. So it just auto sources from the SVI for that. In iOS 16 and up, it changed to the device tracking auto source command. Device sensors helped capture the DHCP, CDP, and LLDP information. Now, this is useful because it packages it up in a radius accounting packet and sends it to ICE that way. A lot more efficient for ICE to manage that for profiling. And if you do the device sensor for DHCP, you don't have to put an IP helper address on every SVI and point it to one of the ICE PSNs. So you get the bonus feature of not having to send DHCP requests to your ICE server, and it's guaranteed that the profiling data, the DHCP information, goes to the same PSN where the authentication occurred. So if you have a laptop, you plug in, it goes to PSN 1, but you had an IP helper pointed to PSN 2, you can see where the profiling is not going to the same place, and so it's not very efficient. Whereas with the device sensor, we're sending it to the same PSN, and it can process it at the same time. DHCP snooping does have to be configured. And device sensors were actually introduced in 15.0 and iOS XE 3.6 on some platforms, not all. So you will, if you do run across some older devices, not sure, you have to check to see if the command is available on there. And just so you know, no, IBNS 2.0 is not a requirement for device sensors to be enabled. You can enable it without moving to the new style authentication. Here we have the device sensor configuration. As an example, my DHCP, it is very important to create a filter list and a filter spec, because you don't want to send every possible option and every possible type length value, which is a TLV, to ICE. It's a waste of space. It's a waste of time for ICE to process it. Narrow it down to what you need. So in my example for DHCP, I'm sending a host name, requested address, class identifier, and client identifier in my filter list. And it's assigned to DHCP with the list name of DHCP_list. Very straightforward. Once you create the filter list, you actually need to assign it. That's what the filter spec is for. You assign the list to a protocol sensor so that it knows, hey, I only want this information. The send all changes to ICE, that's what the device sensor notify all changes. We're going to disable the local device sensor processor. We're just going to send everything to ICE because that's where we want it. We want ICE to do what ICE can do with it. We don't care if the switch shows us that it's a certain IP, a Cisco IP phone or whatever. We want ICE to get all the info and take some of the processing off the switch. After you get that configured, it will sit there, but it doesn't actually send until you set an access session attribute filter list. What sensors do we want? What protocols do we want? If we only wanted DHCP, we would only include DHCP. I like to include CDP, LLDP as well, because as you'll see in the example I want to pull up, we glean a lot of information from it. Just like the device sensor, if you create a filter list, you got to assign it to a filter spec. And in this case, the access session accounting attribute filter. So send this information in the accounting list to ICE, in the accounting packet to ICE. Here, I'm going to show an example of what I'm talking about. The video, I did have to speed up a little bit for time constraint. So it's going to be a little fast at first. You'll see me look at a device, show the default profile that ICE sees it as, which is going to be a Cisco-device, because the only thing we know is the Mac OUI. And then we're going to look at the details of the endpoint. And first thing you'll notice is there's not going to be any CDP, LLDP, or DHCP information under the other attributes. So we scroll down through here, no information available. And now let's go on to the switch. Let's put on the device tracking, put on DHCP snooping. That DHCP snooping trust for the uplink port must be enabled. Because if you don't trust the uplink port, it's going to drop the packets from any DHCP server coming in, which obviously that is bad. Now we have our DHCP. We see the access session is on that port. We can look at the device sensor cache and see we've captured DHCP, LLDP, and CDP information. Let's go back under ISE. Now we actually see it's the IP phone, and we have an AP. When we look at the attributes, we now have all that information that we can base a profile off of. So we have the CDP info showing it's a Cisco IP phone 6901. We have the LLDP information showing the same thing. So a lot more efficient, a lot better than IP helpers to capture DHCP and an SNMP configuration to try to pull CDP and LLDP from it. Instead, we just packaged it all up, sent it to ISE in an accounting packet, and done. Now we're going to look at the actual IBNS 2.0 specific configurations. What's actually part of the new style? We have service templates. Service templates we use to apply certain attributes to a session. Like these two examples I have here. I have a critical access service template on the switch. I'm going to assign VLAN 100 and an access group, which is an ACL named AAA-down. So that AAA-down is an ACL I have configured on my switch to limit what access they have if somebody is assigned critical access. And then as far as the voice, if we want to assign the service template critical voice, assign the voice VLAN. The nice thing about service templates is you configure them on the switch, or you can dynamically push them from ISE in an authorization profile. You can also assign service templates either via a policy map or dynamically by ISE through Radius. Service templates also go along with control classes or class maps. And what these classes are, they're conditions that you put into a policy map that has to be true. So if you have like this class map at the bottom where I have AAA down unauth host, that if we call that in a policy map, it's going to try to match on AAA is timed out, so we could receive no response from ISE. So we'll say the WAN connection's gone down. And the current authorization status of that session is unauthorized. That's great. What do we do with that information though? Well, we use it in a policy map. So a policy map ties together an event, a class, and what action to perform. Using our previous example of the unauth host, you'll notice as you go down this list, so you have the policy map here, you have an event session started, .1x, it fails. So we have the authentication failure. What are we going to evaluate? we're going to hit this class because this is going to match true. AAA is unavailable. The endpoint is unauthorized. What do we do with it? So policy, event, class, and then the actions. And you notice we have multiple actions. We're going to clear any authenticated host, and we're going to activate those two service maps. So assign VLAN 100 and that ACL, assign the voice VLAN. We're going to authorize the connection, and we're going to temporarily pause reauthentication because there's no reason to keep reauthenticating if AAA is down. Later on in the policy map, if you go to my site and you pull up my policy maps, you'll see where there is a class check for AAA's back available. When that hits, the port goes back through reauthorization. So that session will get reauthorized and try to match it with ISE to an actual authentication authorization policy. Here we're going to go through, assign our service template, our class maps. And one thing I want you to notice is when we get down near the end of the policy map, I have a failure. Class map does not exist. Why is that? Well, notice not critical auth was spelled with a lowercase a, whereas my class map has a capital A. So that's where case sensitivity will bite you if you don't have it in there correctly. So you have to make sure if it says something doesn't exist, check your spelling, check your case. Converting to new style actually occurs one of two ways. You can either explicitly run the authentication convert new style command, and it'll convert everything to the new style C3PL. Or if you try to apply a configuration command that is new style, like AAA accounting identity versus AAA accounting .1x, it will prompt you, are you sure you want to do this? And so when you apply new style, one of two things can happen. If you don't have anything configured on the switch, it's fine. It'll just go through, everything will work fine. The problem is if you have an existing 802.1 configuration on the port. And so we're going to look at existing policy maps. There's two policy maps existing. So now we're going to display the new style, not convert, just display. To see what would happen if we converted to new style. Well, now, because I have two ports, port 1 and 2, configured with .1x, it's created two policy maps, one for port 1, one for port 2. So now we're going to go back, and that authentication display legacy takes us back out of the new style, and we can see that those are gone. But this is what you have to watch for. So if you have multiple ports configured for .1x authentication, and you go to convert to new style, it's going to create a policy map for every single port. And it's going to assign that policy map to that port. It doesn't matter if you have the exact same configuration on the port. It's going to create a new one for each one. So how do we get around that? One way to do it is you can either, before you convert, default the port so that it has no authentication, no settings at all, or just remove the authentication settings. And I'll show you what I'm talking about in this example, where we're going to see the config. We see that we only have the default policy map. And then I'm going to go into the configuration. I'm going to go into the two ports that we saw previously and just remove all the authentication settings. Now, when I do the display new style, we'll see that we don't get per port policy maps created. So this is something you could run before you apply the full config and before you start applying the new authentication settings and device sensors and service policy maps and everything, so that you can have your own policy map to assign to the ports, along with the port templates that we'll look at. This is literally my favorite feature of IBNS 2 is the switch templates, because it removes a lot of the bloat. Instead of pasting 15 lines of config for every single port, you create a template, you apply one line to the port. One thing to keep in mind though, not all the commands for the configuration are available in a port template. So there may be some commands that you have to apply to the port template, but then also apply to the port directly. Ran into this with some older versions of 15 that were converted. There was no .1x timeout available in the port template. But then on another switch, I was running 16, I could put the .1x timeouts in the port template. So in the older switch, I had to create the template, but then apply the timeout values to the port itself. Usually customers that I work with, they'll do like two templates. One template is for the monitor low impact, which is designated by the no access session closed right there. And then they'll have a closed mode port template where you see the difference is we just enabled access session closed. One interesting note, if you only did one template, so the port 1.1x default, if you have that assigned to ports and you go in and you modify the template to where it's just access session closed, it will affect all ports. So anytime, if you have a template configured and you have it applied, it will, any changes you make to the template will affect those ports immediately. You won't lose connection, just moving to access session closed, but it will affect new sessions coming across. When you actually assign a template to a port, we have the three methods of access. We have monitor, low impact, and closed mode. So monitor mode, we would just use the port.1x default that I just showed that had the no access session closed, and then a device tracking policy. If you look at the low impact mode, we assign the exact same template, but we've assigned a local ACL so that it limits what they can talk to before they're actually fully authenticated and authorized. So your ACL, your local ACL could assign DHCP, DNS allowed before it's actually fully authenticated. And then in closed mode, we assign the port.1x closed template that has the access session closed enabled on it. Here we can see I default create the port template. I default my interfaces, and then I assign the two interfaces with the port.1x default. Notice 2 lines of code. But if we use the derived -config, now we see the full configuration that is applied on that template. So if you just do a show run, it's only going to show you the template assignment. You have to use show derived config to get the full configuration that's assigned. And notice at the bottom that service policy type control subscriber .1x default. That's the policy map. That's the policy map that we assign this template to assign all sessions that come across that port. The big question we get a lot is, the IBNS 2.0 can do simultaneous MAB and .1x. Yes, it can. But we do have to warn you, if you do this, you are increasing the load on your server, your ICE node, because if you have a .1x client, it's going to send a MAB request and .1x. So that's 2 sessions for one device. So you can see where this can get big really fast. So if you're going to do this, use it sparingly. Main locations I've used this in is in heavy IoT environments, manufacturing floors that have a lot of IoT devices like PLCs and temperature sensors and things of that nature that are sensitive to a .1x timeout. Silent host, that if it doesn't detect an immediate connection to the network, it just stops talking to the network. So if we do simultaneous MAB.1x, we can get it onboarded faster for those situations. In this example, I'm going to apply the policy map to do simultaneous .1x and MAB and show what happens when a .1x client is connected. So here I'm modifying the policy map, and I no shut my port, and notice MAB stopped, .1x succeeded, and MAB stopped because of the .1x. Even though MAB stopped, when we look in ICE, we have 2 records. The bottom one is MAB, because MAB is faster, right? And then the top one is the actual .1x. So we have successful authentication for .1x. That's cool. What about MAB clients? Because that's the big complaint. No matter what, if you set your timeout to 7 seconds with 3 retries, that's the 21-second timeout. That's a long time for some IoT devices to wait to get authorized via MAB. So let's take a look at what that happens when we have that. Right now, no session. We're going to apply the policy in MAB. We're going to no shut the interface. Immediate MAB authorization. No timeout for the .1x. And notice we only have 1 session. We have 1 session because there was no ePOL from the endpoint to trigger .1x. So that's why we have MAB.1x stopped. And that's what I have for you today. Hope it was informative. If you have questions, we have a lot of resources that you can utilize. The iceberg, Thomas Howard is doing a great job keeping that updated. And we can always add more. So if you have anything, any configurations, examples, let us know. We'll add it to the encyclopedia. That way we can share this information. The YouTube channel is great because we have all our past webinars there. And you can see other sites that we have. Please fill out the survey. A little nervous asking for that, as this is my first webinar, but hopefully did a decent job, and I do appreciate you being here. So when you get that pop-up, just fill that out and just let us know how we did and any other topics that you'd like to see. Thank you very much for your time.
Excellent. Thank you very much, Brad. Brad, if it's okay with you, there are a couple of outstanding questions from the audience. Is it okay if we try to address some of those live here for them?
Absolutely.
All right. So I do have one of the questions here. During the upgrade to iOS 15.2 to 16, to above 16, will the device tracking command syntax get reconfigured automatically?
It might. That's one of those might questions. It is very important that if you do the upgrade, you validate your commands. If they did not update, there is a command. If you go, we have an ICE wire prescriptive guide. There's a command there that you can run that will update it for you if it didn't automatically update.
Awesome. Thank you so much. Another question that I see here is, would you also disable device tracking on an AP port trunk?
Yes, because it's a trunk.
Got it. And there's another question here that might be of the same nature here related to this question here. Would you still enable device tracking on a non-switch trunk port?
I haven't come across any reason to, outside of in case you're wanting to build that tracking database locally on what's coming across. The problem is a lot of the trunks go to other switches that have other devices coming across, and if it daisy chains down, you're going to start building that really fast. Going back on the wireless, the AP question, I did want to add, your device tracking is going to occur on the wireless controller there. That's why you don't really need it on the wired port, the switch to maintain that.
Got it. Thank you so much. Another question here from one of our audience members. Do you disable the IP helpers sending the data to the ISE completely, or do you have that in addition to the device tracking?
If I have device sensors, I do not use the IP helper. There's no need for it. You're increasing the data being sent to ICE, and you're not going to get any benefit from it.
Got it. Thank you so much. Another question here is, what if DHCP is not used? How is DHCP profiling? How does that work?
That you're not going to get it, right? Static IP address host, you have to rely on other methods for profiling. So if it supports CDP and LLDP, you'll be able to capture that data and use it in a sensor. Otherwise, you have to use other methods. I mean, it could involve using something like cybervision to help profile those devices. There's Medigate, there's Order, there's other systems that actually profile based on traffic. Cisco DNA Center, Catalyst Center, that's another method because you can use the endpoint analytics to help capture that and send some of that data to ICE for profiling.
Excellent. Thank you so much, Brad. Looking at time here, I think we have some room for just a few more questions before we wrap up. Another question that I see here is, if doing concurrent authorization, does it count as 2 times the sessions from licensing perspective?
Yes, it will. And then it will age out the MAB session. I think, if I remember correctly, it's like 15 minutes or so. So it's not an immediate.
Perfect. Thank you so much for addressing that one. And the next one that I have here is the concurrent MAB and .1x being discussed. Isn't that just flipping the priority for MAB to be higher?
No, because if you look back at the priority as a priority 20, it was listed as an event 10, but priority 20. So MAB would hit first and .1x hit second, but priority was given to .1x.
Got it. Thank you so much. And final question here for you, Brad. So you showed the LLDP in your device tracking config. Do you enable LLDP on your switches normally?
Only if I'm using the device sensor, and that is in the templates that I have before I actually configure that filter list and filter spec for LLDP. I include the LLDP run command so that it's enabled in case it wasn't enabled before. Because even if it's not enabled, the switch will accept the device sensor configuration for it. So the filter list and the filter spec, it'll accept it. It just won't run
Got it. Thank you so much. And I'm sorry, Brett, I do see just one more question here. And if it's okay, we'll just go ahead and address that, and then we'll wrap up for today. Um, and that question is, what happens if we remove test user from global or globally, but still configure under AAA server as a automatic tester? Will it be tracked AAA or not?
No. In fact, I haven't tried doing it that direction, but I have found that if you try to do the radius server configuration and put in that user account, it fails because the account has to exist.
Perfect. Thank you so much, Brad. Really, really appreciate you taking the time to address those live for our audience. So with that, last question and answer, we'll go ahead and wrap up our presentation for today. I just want to again, Brad, thank you for speaking about this topic with our audience today. I hope that everyone found great value in the information and resources that were shared here today. I would also like to extend a very big thank you to each and every one of our panelists for lending a hand with all of the questions throughout the webinar. We really appreciate it. And for our attendees, if you do have any additional questions or would like to continue the conversation about today's topic, we do encourage you to participate in our online post-webinar discussion. You are going to be redirected there upon exit, but the link has also been posted into the chat window. So we do look forward to your participation. And just a quick reminder again for our audience that you will receive a short pop-up survey as soon as you exit this webinar. And we would be so grateful if you can just take a few minutes to complete it and let us know how you like today's presentation. We always look forward to receiving your valuable feedback. And for those of you who may be interested in revisiting this session, we will have the recording available on demand within approximately 5 business days after today. And the links have also been posted into the chat window where you can find that for your reference as well. And another quick reminder for the next webinar coming up. So for the month of November, and that'll be November 5th to be exact, we're going to be hosting ISE integration with Splunk. The registration for this session is going to be coming very, very soon, but I posted the link in the chat window there where you can register once that is open for everybody. So we do look forward to seeing you all there next month. Thanks again to our presenter, to our panelists, and to all of our attendees for joining us here live. I hope that you all enjoy the rest of your day. Thank you so much.
Thank you.